Okay, so good afternoon. We'll discuss today the projects that you'll have for the course. First, that you have some time to do some readings and decide on the topic you want to go over. If not yet, please, as soon as you decide on a topic, directly send me the idea you selected, because each group should work on a different idea. Today, I will expose other ideas for the project so that you can decide on one of them if you want, or if not, you can work on any idea related to energy. You can just send me the idea to make sure that it is acceptable and it should satisfy some criteria for the course material. Okay, so today I will expose some possible topics in addition to the ones we discussed last time, because as we said on Moodle, you have several ideas already. You can have access to different articles, to different scientific ideas that can help you into selecting the project that you want to go over. And here also today, I will propose some potential research project topics. And once you decide on the topic you want, directly please inform me. So the idea of the project first, the project will consist of a paper, and you should write a paper that is, if you want, a little bit similar to technical papers that you can find in journals. And you should prepare also a presentation in order to expose your work. Now, you can do it individually if you want, or you can form groups of 2 to 3 students. But as I mentioned before, the larger the number of persons per group, the amount of work expected will be larger. Please, guys, mute your microphones if you are not asking questions. Now, concerning the topics can be scientific or technological and should be extensions of what is covered in the course. You will see that in the course, we'll go over different renewable energy strategies. We'll talk about fossil fuels. We'll talk about greenhouse gas emissions, carbon storage, etc. And therefore, you will, in your work, you will go deeper into these ideas. Okay. Plus, you will try to search for a gap in the literature. So what is the main challenge facing the technology you are going over? And what can we propose to enhance, let's say, the efficiency of a certain system, or sometimes maybe your idea might be to combine several systems to enhance their efficiencies. When we go over the topics, I will explain this. So to begin with, one of the possible topics is electrochemical capacitors as a mean of energy storage in electric vehicles. We have already discussed that energy is present in several forms, and sometimes we have energy in excess, so we need to store the energy. And storage can be in different ways depending on the type of energy. For example, in this topic, we will concentrate on electrochemical capacitors in order to store energy for electrical vehicles. Electric vehicles is a very, if you want, innovative research idea, and we are developing it, and we are working a lot on it, because we're trying to come up with cars that are energy efficient and work on electricity instead of burning fuels. And this will help into reducing the greenhouse gas emissions, and plus will lead to energy savings, because we know that to produce electricity, we can use a lot of renewable techniques. We can use solar techniques, we can use wind energy, and therefore, of course, we prefer to use renewable energy because it's free, and we can we can save, if you want a lot of money, plus we can reduce the bad impact on the environment. Now, concerning electrochemical capacitors, we refer to them as electric double layer capacitors, appear under the trade name of supercapacitor or ultracapacitor. Now, when we say double layer, we refer to their physically storing electrical charge at a surface electrolyte interface of high surface area carbon electrodes. So here, in case we have someone in the chemical engineering field, you might be interested in this topic because it's involved a little bit of chemistry. There are two types of electrochemical capacitors, symmetric and asymmetric, with different properties that are suitable for different applications. Markets and applications for electrochemical capacitors are growing rapidly, and application related to electricity grid will be part of that growth. So this is a possible topic to go over. Another topic, so as we were discussing, depending on the type of energy, storage will be different. We know that, for example, if we have a building and we are using solar energy, during the day we have excess of solar energy, so we might not need it completely during the day. So we need to store it and using during the night. Okay, that's why in this case we need to think about a method to store energy. And one of the basic methods that are used in buildings in order to store solar energy or any type of energy is thermal storage. When we talk about thermal storage, we have different possibilities. For example, let's say one of the main ideas will be the following. Let's say you have your house. You can have underfloor, okay, we put underfloor if you want a slab that is characterized by a high energy capacity. So when solar radiation can be transmitted through glazing, okay, this material is able to store this energy. In general, it will be characterized by a high capacity. You know that if I consider, let's say, for example, any material, okay, its ability to store energy is the following: Q, which is the heat, is equal to its mass times its specific heat times delta T. Okay, you know that the temperature, when you have solar radiation that is entering the space, this will warm the space. And then because of the temperature in the space that is larger than the temperature of the material here, Tm, what will happen is that heat will be transferred to this material, and this material will store it. And higher is the mass of this material, and higher is the specific heat of this material, the storage will be larger. Okay, that's why we have to know about the properties of materials to know if if it's a good idea to use it as thermal storage or not. Okay, for example, you can have what we call water walls in some very big buildings, okay, where you have large glazing facades. You can have like columns of water, because water is characterized by a high capacity. Okay, so let's say when you have the solar energy crossing the glazing, water in these columns can store this energy and then deliver it during the night. So this is also another strategy, but not for if you want normal residential buildings, but for large buildings. So thermal storage is used for electricity generation by using power from the sun, even when the sun is not shining. So the main idea is that the thermal storage will deliver energy when needed. So when sun is not here and we need to heat the space, thermal storage will give us back the energy stored when we had excess of energy. Concentrating solar plants can capture heat from the sun and store the energy in water, molten salts, or other fluids. You have a lot of, if you want, thermal storage types. PCM also is one. Phase change material is one of the possibility. You have materials that can store energy by changing phase, because let's say you know that let's say when you go from solid to liquid state, okay, you need to provide energy. Okay, so let's say you have a material in the solid state, it will absorb energy and be transformed to liquid state. We say then that it's storing energy in latent form. And then once this energy is needed, the energy will be delivered back. And again, you have change of phase from liquid to solid. So PCM is also a type of thermal storage. So in this field, you have several ideas that you can talk about, and you can compare the different thermal storage techniques. This stored energy is later used to generate electricity, enabling the use of solar energy even after sunset. Another possible topic, already wind energy is selected. So already there is a group working on wind energy. Wind energy, but just to, as a summary, you know that wind energy is one of the most used renewable forms. So we have the solar energy that is renewable, wind energy, hydro power, so we can use energy from water. So these are the main renewable resources. Now, in wind energy also, this is a very wide field. You can have wind energy on macro scales. Let's say if you want to have for a certain country supply of electricity, you need larger stations and a lot of space for wind energy. If you are using on a small scale, you want to ensure electricity, let's say for a residential home, then you can work on a small scale and see how wind energy can reduce the energy consumption of your house. Another type another possible topic is coal power plants. So we'll see that we will compare mainly in this course renewable energy to non-renewable energy, like the use of fossil fuels, the use of coal. So we know that coal dominates now the global energy area because we have it in large quantities. So it's abundant, it's affordable, and it's characterized by a wide distribution across the world. Coal, when properly handled, is one of the cleanest fossil fuels available today. So we can treat coal in order to avoid bad effect on environments. So we can study, if you want, what are the techniques used to reduce the harming effect of coal, and how power plants can be installed and what is their cost, etc. We can compare, for example, we can do an economical analysis to compare coal power plant to a renewable power plant. So this is also a possible topic. Now, we know that fossil fuels are used a lot, but the main problem is the release of CO2. Okay, that's why we can think about reducing the bad effect of CO2 and come up with technologies that can use CO2 to be useful in a good form, not to have warm effect to the environment. That's why we one very important field of research is to come up with techniques that can capture CO2 and store it. Then we can use it in power generation and industrial usage technologies. So this is very important because CO2 in general has a very bad effect on the environment. If we can capture it and use it for energy production, this will be really very important, because we can now use, let's say, fossil fuels without having their high negative effect. Plus, we can have power generation from using this CO2. So this is a very interesting topic. We know that global emissions of carbon dioxide from fossil fuels have been increasing a lot by nearly 2.7% and now more per year over the past decade, and are now 60% above the 1990 levels. By contrast, it is estimated that the CO2 emissions should be reduced by at least 50% to limit the rise of the global average temperature to 2 degrees by 2050. The global warming effect is really very challenging, and we should pay attention a lot, because already you can, in Lebanon, if you look at the variation in climate, you can see this change in just these 5 years. So the climate is changing in a drastic way. In general, let's say we have during winter, we had a lot of rain, we had a lot of low temperatures. Okay, now we have nearly, until now, okay, the amount of rain is really small, and even if we compare the snow level to previous years, it's much lower. So this is due to the global warming effect and the increase in the temperature of the Earth. And if we keep going in the same way, and we don't reduce the CO2 emissions, we will have very bad climate effects on the Earth. So that's why we need to think about strategies to reduce the emissions of CO2. That's why we can think about a useful, if you want, techniques that can capture CO2 and use it for good purposes. So a range of different options that could help towards this target for mitigating climate change is CO2 capture and storage. Another possible topic, also related to the topic of CO2, is the potential for mitigation of carbon dioxide by engineered microorganisms. So this is also a little bit chemical. You have another strategy to reduce CO2. A part of the push to reduce greenhouse gas emissions produced by burning fossil fuels, researchers have developed a greener way to extract biofuel from bacteria. The team has genetically modified a cyanobacterium to consume carbon dioxide and produce the liquid fuel, which hold great potential as a gasoline alternative. As an added bonus, this reaction is powered directly by energy from sunlight through photosynthesis. So this is another possible topic that you can work on. Going back to the importance of energy storage, another possible topic is battery technologies for plug-in hybrid electric vehicles. So as we mentioned before, the area of electric vehicles is taking a lot of interest, and we are doing a lot of research to enhance their performance to be comparable to vehicles moving under fuel consumption. So energy storage systems, usually batteries, are essential for plug-in hybrid electric vehicles. Plug-in hybrid electric vehicles will use batteries to power an electric motor and use another fuel such as gasoline or diesel to power an internal combustion engine or other propulsion source. Using electricity from the grid to run the vehicle, some or all of the time, will reduce operating costs and fuel use relative to conventional vehicles. And we can from here try to think about it. Until now, we have a lot of hybrid vehicles because we are not able to rely 100% on electricity. But the idea after will be to completely rely on electricity without the need of fuel. So with the advance of technology, we'll be able to reach that level with comparable energy performance, of course. Now, another possible topic is Stirling engines. Stirling engines is also a very interesting technology, and it is expected that it has an important future. A Stirling engine is a heat engine that operates by cyclic compression and expansion of air or any working fluid at different temperatures, such that there is net conversion of heat energy to mechanical work. As we mentioned in this course, we'll be interested to see how energy can be converted from one form to the other and how we can produce useful work. More specifically, the Stirling engine is a closed cycle regenerative heat engine with a permanently gaseous working fluid. In this course, we have a chapter dedicated for, if you want, the study of cycles, and we'll understand more how thermal systems can work, how we can improve their efficiencies, etc. So this topic is related to this part of the course. Closed cycle in this context means a thermodynamic system in which the working fluid is permanently contained within the system, and regenerative describes the use of a specific type of internal heat exchanger and thermal storage known as the regenerator. Another possible topic is smart grids. And smart grids are very important, and it is already, if you want, smart grids are already used in a lot of developed countries, and it allows to increase a lot the efficiency of the energy delivery by the grid. The smart grid is an electrical grid which includes a variety of operational and energy measures, including smart meters, smart appliances, renewable energy sources, and energy efficient resources. Electronic power conditioning and control of the production and distribution of electricity are important aspects of the smart grid. And for example, let's say in developed countries in Europe, for example, when you construct a house now, you can include a lot of passive strategies in order to reduce the energy consumption, and you implement, let's say, a solar system, wind energy system that allow you to use the solar energy to produce electricity. Now, these systems will be connected to the grid of the country, and then in case you have an excess of electricity, you can sell this electricity to the state, okay? And in case you have, let's say, sometimes you need electricity from the grid, it will supply you. So in this way, we can benefit on the macro scale from all extra reserves of electricity, of energy. And in this way, we can use the solar energy in a more efficient way, because even if you have a storage system, your storage system will have a certain capacity. And once it's full, if you have any extra, you will not use it. In this way, any extra will be delivered back to, will be connected to a grid working on the macro scale, and then you can increase a lot the efficiency of using the energy. Now, another possible topic is hybrid power plants. Hybrid power plants constitute the future for intermittent renewable energy sources. What do we mean by this? We know that renewable energy is becoming more and more attractive, but we still have some, if you want, technical issues. We are not able to 100% rely on renewable energy for different causes. So first, for example, let's say when you use a solar system, we know that the solar energy will not be at the same level for all days, and you have some days where you don't have the sun. So you cannot say I can rely completely 100% on solar energy in some countries. That's why you can like have several systems working at the same time, and they can help each other. So when we talk about hybrid, we are using several sources of energy, and then let's say you have a solar system, you have a backup system that can be used when your solar system is not able to satisfy your needs. And hybrid power plants will often contain one renewable energy component, let's say such as photovoltaic system, that is balanced through a second form of generation or storage, such as a battery storage system, or sometimes you can couple, let's say, solar energy and wind energy. This works a lot in Lebanon, because in Lebanon, the majority of days you have wind, and especially during winter where the sun is not available a lot, you can rely more on wind energy, while during the summer you have lower velocities for wind, but you have more sunny hours, so you can then rely more on the solar system. So by combining several energy resources, you can be on the safe side and you can satisfy your needs. So these are other possible ideas. So until now, in the first sessions, we introduced some ideas. Now, other ideas. So you have a lot of possible topics. If you are interested in one of these, you can directly send me a message after the session by WhatsApp to reserve the topic for you. Okay, so you can start to work on it. And in case you are interested in another idea, you can propose it to me, as I mentioned before. Okay, now concerning the project content, okay, we'll try to, if you want, the purpose of this project is to introduce you a little bit to the way of writing scientific articles. So whenever, let's say you are doing a research, okay, and you want to propose a new idea, what do? The first step for you will be to read several articles in order to know what we call the state of the art concerning your topic. What we mean by this, what was done until now, what are the main challenges of the system, how we can tackle them. So when you have some reading, you can know what is the state of the research, or what are the systems that are used now, and you can identify what is the gap, what is the main, if you want, problems facing this technology, how we can improve it. So you should start to ask yourself, what can we do? I know that for this work, and it's a mini project, it's not a PhD thesis. I know that you will not be able now to get completely an original idea from zero. It's fine, I know this, but at least you can try to, for example, just do some brainstorming to propose, let's say, a small enhancement in a system. No need, of course, to have the system, to propose a system from zero. You know that many of the research work now is just enhancing a system, or proposing or doing a small contribution to enhance the energy efficiency. Sometimes your idea might just be to combine several systems together, because in this way you can increase the energy efficiency of the system. So when we say literature review, what we should do, we should go over several scientific articles. Please always, when you search for references, try to have reliable references. In AUB, you have access in the libraries to very important journals. You have access to Elsevier. In Elsevier, you have several possible types of journals, like, for example, energy and buildings, building and environment. You have solar energy. You have a lot of journals that are related to the energy field, okay, and that compare, let's say, renewable energy to conventional sources of energy. So you can access the libraries and get articles, reliable articles to use in your research. If you want to use books, you can, but in general, articles can give you, let's say, a wide view of what is the trend of the scientific topic you selected now, and what are the main challenges facing it. So you can have an idea on what to work on in your project. So once you have some readings, you can introduce the project and state your objectives. Then in the body, okay, in the body you can, let's say, for example, let us take an example. Okay, let's say you selected, for example, solar energy use for domestic hot water systems. Okay, you want to heat the hot water. You want to heat water for domestic purposes. Okay, then you can go and see what are the systems that are used now. You have several possible systems. Okay, let's say you can concentrate on one if you want, and try to see how the system was developed with time. Let us say photovoltaic systems, PV cells. Okay, if we have some readings about PV technology, we can see that it faced many challenges to reach the current state, because at the beginning, first, one of the main limitations of photovoltaic cells is that during the process, okay, you have heating of these cells. So the temperatures of the cells will increase. But we can observe that the efficiency of PV cells is drastically reduced by the increase of temperature. And this was one of the main obstacles in development of this technology. Because let's say you are in an Arabic country, and the temperatures reached are really very high. So you can easily reach the temperature, the limiting temperature of PV cells. Let's say for PV cells should not exceed 70 degrees. Okay, and whenever solar energy is directed towards the PV cells, you can easily reach such temperatures. So when you reach this temperature, the energy efficiency of the system will be reduced a lot. And therefore, this will be a limiting factor, because when you can reach this temperature in a very fast way, and then your system will not perform well if you exceed this temperature. So that's why we try to think about different ways to reduce first the temperature of the PV cells. So we started to think about installing a cooling system that can reduce the temperature, continuously cool the PV cells in order to avoid reaching very high temperatures. Plus, we developed the material that is used in photovoltaic cells in order to increase, if you want, the limiting temperature. So we work on several issues in order to make photovoltaic systems viable and use them in countries where we have very high temperatures. So from here, for example, you can study the progress of the PV technology and look at the recent challenges. What are the recent challenges facing it? And you can do some brainstorming and see recent articles are proposing which techniques to do in order to enhance the performance. So this can be, for example, one of your topics. In case you selected this topic, when you want to, in the body, you will describe, if you want, the progress of PV technology, what are the methods used, how we were able to develop these systems, what were the main scientific technologies used in order to enhance performance of PV cells. You can talk about the current state, what are the challenges that we are having now, and provide some recommendations for future enhancement of these systems. And at the end, of course, the first part of the report is the abstract, but the abstract we write it at the end, because the abstract will summarize the project content and its main findings. And what I want from you also is to add, like, a very important aspect that we'll tackle in this course is the economical analysis. In general, whenever we are developing an engineering system, what maybe our idea will be very, very original, and scientifically it's a very important idea. But if we don't perform an economical analysis for it, okay, and make sure that it is economically viable, then the system will not be, no one will invest in such system. Okay, that's why we should always try to add an economical part at the end, okay, to talk about let's say the prices. We'll develop in this course, at the final chapter of this course will be how to perform like an economical analysis and how to know if a system is profitable or not. But I think that the majority of you have already taken economic courses and engineering economics mainly. I think you have taken this course, so you can use the different tools you developed in these courses to study your system on the economical level and make sure that, let's say, the payback period is acceptable. You can assess the incomes and calculate, if you want, the net present value at the end of the lifetime, to make sure that you will earn enough money, because whatever is my system and my idea, maybe my idea is very interesting, but if it will not give me an income, no one will go over it. Okay, and you know that at the beginning, when we started to use renewable energy, the main challenge was the cost, because any new idea that you propose at the first stage, the cost will be high, because you are starting a new technology, you are putting a high investment in it, and not everyone can go for it. That's why for developed countries, the state in general helped a lot the initialization of renewable energy projects, because the state can play a very useful role. For example, let's say in Europe, even if when we started to use renewable energy, electricity using fossil fuels was cheaper than electricity using renewable energies, but the state forced people to put renewable energy, and they if you want, they started with a high cost and reduced the cost with time in order to have a balance between the investment and the cost and have an acceptable payback period. So because the state forced people to use renewable energy, it was possible to implement it, because no one will go for it if fossil fuels is cheaper, unless you have some regulation that can force people to use this strategy. And this is how renewable energy was able to be developed and to be implemented in developed countries. And for example, now you can see that in Lebanon, now we started to think about it, but we should have done this way before, because we have a lot of sources for renewable energy. We have solar energy at the majority of times, we have wind energy, we can benefit from water energy. But because of the if you want, of the bad use of fossil fuels, and because always people, during this years, the electricity cost before the crisis now was acceptable. That's why no one tried to the renewable energy projects were really limited in Lebanon. But now with the problem of dollar and lira and the shortage in fuel, then we started to think about free resources and we started to use renewable energy. And of course, at the end of the project, you should make a small conclusion summarizing, if you want, the state of the research you did and what were your main conclusion and recommendations that you can give. And finally, of course, you should put the references that you used in your work. So this is, in summary, the content of the project. We'll continue discussion. I will open a new session.